Hi, welcome to my video on simplified trig expressions by factoring. So the factoring rules that we had with the algebraic expressions are the same factoring rules I'll use on simplifying trig expressions. Factor each trig expression. Remember, the first rule in factoring is there a GCF? I'm going to look at 7 sine theta, 7 cos theta. 7 is the GCF. So I'll take the 7 out. 7 sine theta divided by 7 is sine theta. Plus 7 cos theta divided by 7 is cos theta. B, I see cos squared, subtract cos. I see cos is the GCF. So I'll take cos theta out. So cos squared theta divided by cos is cos theta. Subtract cos theta divided by cos theta is 1. Remember, if you multiply the cos theta by both of these, you should get this expression. If you multiply 7 by this binomial, you should get that expression. C, what's common? I see a sine theta in both expressions, so I take the sine theta out because that's the GCF. So sine cos divided by sine is cos theta, and sine divided by sine is 1. Okay, and D, there's nothing common, but notice this is the difference of two squares. This is 1 squared, subtract cos theta squared. So that's going to be 2 brackets. 1 is 1 times 1. Cos squared is cos theta, and we have a difference of 2 squares, so we have a plus and a minus. So if we did the FOIL on these two binomials, you would come up with this binomial here. And E, notice I see a sine squared, 3 sine plus 2. This is a trinomial, but it's in terms of sine. Just think of it as x squared plus 3x plus 2. So the the sine is being treated the same as the x. So it's a trinomial where we have a product of 2 and a sum of 3. So that means to get sine squared, we have to have sine theta times sine theta. The product is plus 2, so there has to be the factors of 2 and 1. And when you add the 2 and the 1 together, you get a plus 3. So the product is positive, sum is positive, so it's a positive 2, positive 1 factorization. And in F, I see, it looks like the difference of 2 squares, so I see 2 sine theta squared, subtract 1 squared. So again, it's the difference of 2 squares. So that gives us 2 brackets. In first bracket, I have 2 sine theta. In this bracket, I have 2 sine theta. So if you multiply these two together, you get 4 sine squared. The factors of 1 are 1 and 1. And because the product is negative and there's no middle term, sum is 0, we have a plus 1, minus 1. Again, is the difference of 2 squares. The same terms as in each bracket except plus minus. So let's simplify these. So work these out, pause the video and work one out at a time to see if you can get them right. Here we go. Simplify. I see a 6 as a GCF, so I'll take it out. 6 cos squared theta divided by 6 is cos squared theta. And 6 sine squared theta divided by 6 is sine squared. And notice cos squared plus sine squared. Well, if you have it memorized, that's 1. So 6 times 1 is 6. And number 4, I see a binomial. I see 4 is the GCF, so I'll remove the 4 out. 4 divided by 4 is 1. And 4 cos squared divided by 4 is cos squared. And 1 minus cos squared is sine squared. So that's 4 sine squared. Also, if you think about it, we could also go with 4, and this is the difference of two squares. So that could be, difference of two squares could be 1, 1. Cos squared is cos theta, and plus 1 minus 1. So you could go this way and get sine squared times 4 to get this expression, or you could factor this and get this expression. You'll know what to do when we start proving the identities, which way to go. Okay, here we go. Number 3. What's common? I see a cos theta in both expressions. So cos theta comes out as a GCF. Cos theta divided by cos is 1 minus cos theta sine squared divided by cos theta is sine squared. And again, we got two choices. Let's either or. We could go cos theta, and 1 minus sine squared is cos squared. And cos times cos squared, that's a 1 and that's a 2. We add the exponents, so it's cos cubed theta. So if I change the 1 minus sine squared to cos squared, I get cos cubed. Or I can leave the think about the factoring, and that what we have is difference of two squares. We have a 1 and a 1. We have sine theta and sine theta, and we have the difference, so it's a plus and a minus. So either way you can simplify. Again, you'll know which way to go when we go through working out identities. And number 4, I see a 6 as a GCF on the top. So I'll remove the 6. 6 divided by 6 is 1. 6 cos squared divided by 6 is cos squared. And that's over 3 sine. And that gives me, let's go up right here. Notice that 1 minus cos squared is sine squared. All over 3 sine. And 6 divided by 3 is 2. Sine squared divided by sine is sine theta. Again, I could factor this, but if I did factor this as 1 plus cos, 1 minus cos, I wouldn't be able to simplify it any further. But because I changed 1 minus cos squared to sine squared, then sine squared divided by sine, 2 subtract 1 is 1. That's a 1 there. And when we divide, we subtract the exponents, we get a 1. Number 5, we have 1 minus sine squared. That's cos squared. Okay, let's try this. Okay, notice now when I change 1 minus sine squared to cos squared, it will not go any further. But if you did the 1 minus sine squared into 1 sine theta plus minus, because it's the difference of two squares, all over 1 plus sine theta. So if you went this way, notice the 1 plus sign is a factor. 1 plus sign is on the bottom, so they cancel out. So I get 1 minus sine. Again, you'll see in identities which way to go, because both sides have to be the same. So again, you can do either or, but this is the better way to simplify to 1 minus sine. And number 6, I have a numerator and a denominator. In the numerator, I see a sine in both expressions. So I'll take the sine theta out as a GCF. Sine divided by sine is 1. Cos sine divided by sine is cos. Notice I'm leaving theta off because the angle is the same. And the bottom is 1 plus cos theta. And because this is factored, and so I can cancel the top and the bottom, 1 each. So that ends up to be sine theta. Again, how'd you do? Hopefully you pause your video and you work them out. And now we have more practice. Again, do one at a time. and press playback. Number 7, cos squared minus sine squared. Well, look on the bottom, we have a cos sine. This is the difference of two squares. So the difference of two squares, that's a cos theta. Sine squared is sine theta and sine theta. And it's a difference, so it's a plus and a minus all over cos theta minus sine theta. So this is the difference of two squares that I factored. And notice cos minus sine is a factor. So I can cancel these two out, and I get cos theta plus sine theta. And number 8, notice I have a sine minus 1 minus sine squared. So I have a sine theta minus 1, can't do anything with that. 1 minus sine squared is similar to sine minus 1, so that's, again, the difference of two squares. So let's go 1, sine theta. That's a plus and a minus because this is the difference of two squares. That's 1 squared minus sine squared. There it is. And notice now that this is sine minus 1. This is 1 minus sine. So they're the reverse of each other. So if I reverse the order here, and if I take out a negative, because this is the negative, notice this is positive sine, this is the negative sine, this is negative 1, and this is positive 1. So if I take a negative out of this, it makes it a negative sine theta plus 1. And this is 1 plus sine on the bottom, 1 minus sine, that's on the bottom. And notice now that these two are the same. So that's a negative sine, that's a negative sine, that's plus 1, that's plus 1. So they cancel, and this gives me negative 1 over 1 plus sine. So be careful. Again, repeat. Notice these are the opposites of each other. Plus, minus, minus, plus. So you, without doing this, you could cancel these two right here, right now, and put a negative 1 there, put a 1 there, and you still get the same answer. And number 9, we have a 2 is a GCF. We have a cos theta plus 1. So 2 cos divided by 2 is cos. 2 divided by 2 is 1. And on the bottom, we have, notice, we have a trinomial, which is cos squared plus 2 cos plus 1. Again, that's like x squared plus 2x plus 1. So the cos is the same as the x. So that means I can use double brackets. And cos squared is cos theta. The product is plus 1. So that's a 1 and a 1. Product is positive, sum is positive, so it's positive 1, positive 1. And notice now that you have it factored. Cos plus 1, either one of these, this one and this one will cancel. So I'll get 2 over cos theta plus 1. That's what's left. Okay, number 10. And I see a GCF, which is the first rule in factoring. Always look for the GCF. I see a sine. Sine theta is common to both terms, both expressions. So sine theta, cos squared theta divided by sine is cos squared theta. Sine cubed divided by sine is sine squared. Again, notice you're dividing, so that's a 3 and that's a 1. So we subtract to get the 2 and check back. Sine times cos squared is this expression. Sine times sine squared is sine cubed. And we have cos squared plus 1. Cos squared plus sine squared is 1. And 1 times sine theta is sine theta. Okay, remember, Again, are you pausing the video? Are you working them out? How are you doing? Hopefully everything is going okay. Because remember, cos squared plus sine squared is just trig identity. And 1 minus sine squared is sine plus 1 plus sine, 1 minus sine, etc. So notice the difference of two squares, factoring rules. Number 11. The numerator got a cos as a common denominator. Cos as a common denominator. Cos is the GCF, so I'll take cos out. Cos divided by cos is 1. Cos squared divided by cos is cos theta minus. Your denominator has sine as a GCF, greatest common factor. So sine cos divided by sine is cos. Remember, I'm not saying theta because it's understood. Sine divided by sine is 1. And note that 1 minus cos and cos minus 1 are opposites of each other. Again, that's a positive and that's a negative. That's a negative and that's a positive. So I can cancel those out and get a negative 1 now. So that's a negative cos theta over sine. And that could also be, if you wish, you could have a cos over sine is cot. So again, you'll know which one to do when you get to identities. You have to wait another video, then I'm starting identities. I'm doing all these simplifications to get ready to prove identities. And number 12, we have tan squared, cos squared, and sine to the fourth. So let's change tan to tan is sine over cos. So tan is sine over cos, so tan squared is sine squared over cos squared. So I have the tan changed. Okay, now we're multiplying here and subtracting here. So BEDMAS says, or PEMDAS says we have to. There's no brackets, there's no powers, and we're multiply before we subtract. So we multiply these two, we cancel those out. So we get sine squared theta minus sine to the fourth. Okay, now you notice that sine is in both terms. So the smallest exponent is 2. 2 that's a 2 and that's a 4, so the GCF is sine squared. So sine squared divided by sine squared is 1. Sine to the fourth divided by sine squared is sine squared. Remember, when you divide, you subtract the exponent. 4 subtract 2 is 2. And notice we have 1 minus sine squared is cos squared. So this is sine squared theta and cos squared theta. Again, this could become 1 plus sine, 1 minus sine. But if you change it to 1 minus sine squared to cos squared, then you get the simplification of sine squared times cos squared. And number 13, we're going to simplify this, and I see I have two choices here. I can simplify tan, or I can see that sine theta is a common factor. So sine theta divided by sine theta is 1. Sine squared theta, tan squared theta and sine divided by sine gives me tan squared theta. And if you can remember, 1 plus tan squared, tan is sine over cos, so 1 plus tan squared is secant squared. It's one of the identities, Pythagorean identities. And so this is sine theta. Secant squared is 1 over cos squared. And so this is sine theta over, that's over 1. So 1 times sine is sine. 1 times cos squared is cos squared. And I could keep on going, but again, that's as far as I want to go. I could also change the tan. So how about if somebody says, well, what's tan? Tan is sine squared over cos squared. So tan is sine over cos. So tan squared is sine squared over cos squared times sine. But no matter what you do, it'll end up to be the same. So it'll come out in the end. So I change the tan to sine squared over cos squared, and so this is a multiplication, so I'm multiplying it sine cubed over cos squared. And notice now, it's going this way. When I did 1 plus tan squared, right here, by taking the sine out, I recognized that was a secant squared. This made it much easier to do. Now this is not going well. So now I got to get a common denominator, so I got to multiply this one by cos squared theta over cos squared theta. So that gives sine cos squared all over cos squared, because when you're multiplying, so sine times cos squared is right there. Cos squared times 1 is there, and I get sine cubed cos squared, and note that becomes sine theta cos squared plus sine cubed all over cos squared. So you'll end up doing the same idea. Now we got a factor at the top, and so watch what happens. So if I take the sine out of the top, because the sine, I get cos sine squared all over cos squared, and that's sine times 1 over cos squared, which is right here, sine theta over cos. So what I'm demonstrating here, because we went this way, we had to add these fractions and get common denominators, and then we still had to take. So the sine that I had to factor out the sine here in order to get this expression, which is equivalent to 1. So if I factored out the sine right at the beginning here, and I recognized that 1 plus tan squared was secant squared, then the problem became much easier. This is much longer, but it still works if you do steps correctly. It still works. And I wanted to end on this problem to show you could go two ways, but learning the identities, like 1 plus tan squared is secant squared, or 1 plus cot squared is cosecant squared, and all the other ones, but these are 1 plus tan squared is secant squared, is one that, again, is not used that often, but you have to keep it in mind, you have to memorize it. And that's my sheets that I copied off. If you like my video, click the like button, subscribe button, and notification bell, and visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.